In today's rapidly evolving digital landscape, the need for efficient application development, deployment, and scaling has become paramount. This is where containerization has come to play. Hello everyone and welcome to today's topic on Kubernetes versus Docker on Intellipaat. Today we will explore the fascinating world of containerization and compare two popular containerization platforms, which is Kubernetes and Docker. Now before we move on and learn more about Kubernetes and Docker, I request you guys that do not forget to hit the subscribe button and click the bell icon. So first we are going to start with an introduction where we will discuss about definition and importance of containerization and introduction to Kubernetes and Docker. Moving ahead, we will be understanding Docker, where we will discuss what is Docker, Docker architecture and components, key feature and benefits of Docker, and use cases for Docker. Then we will explore what is Kubernetes, Kubernetes architecture and components, and key features and benefits. Then we will discuss the differences between Kubernetes and Docker, where we will study about container management versus containerization, scalability and orchestration, networking and service discovery, resource utilization and efficiency, high availability and fault tolerance, complexity and learning curve. And at the end, we will discuss conclusion, where we will recap the key points. Then we will discuss what to choose, Kubernetes or Docker, and at the end, future trends and considerations.
In today's rapidly evolving digital landscape, the need for efficient application development, deployment, and scaling has become paramount. Since then, containerization has revolutionized the way we package, distribute, and run applications, thus offering numerous benefits such as consistency, portability, and scalability. By encapsulating an application and its dependencies into a lightweight, isolated unit called a container, developers can ensure that their applications run seamlessly across different computing environments from the development to production. Now we'll move on and understand about the importance of containerization. The first one that comes up is application portability and consistency. Containerization plays a crucial role in ensuring that the application portability and consistency across different environments. By encapsulating an application and its dependencies within a container, it becomes independent of underlying infrastructure and operating system. This enables applications to run consistently across development, testing, staging, and production environments. Containerization eliminates the notorious "it works only on one machine" and the problem, simplifying the deployment process and reducing the compatibility issues. The second one is efficient resource utilization. If I talk about efficient resource utilization, containerization provides efficient resource utilization by allowing multiple containers to run on a single host. Containers shares a host operating system called kernel, reducing overhead and eliminating the need for running multiple virtual machines. This results in optimized resource utilization, reduced infrastructure cost, and improved scalability. With containerization, organizations can achieve higher density of applications on their infrastructure, thus effectively utilizing the computing resources. And finally, we have simplified deployment and scalability. Containerization simplifies the deployment and scalability of applications. Containers are lightweight, self-contained units that can be easily created, replicated, and distributed. Developers can package their applications along with their dependencies into a container image that can be deployed on any container runtime environment. This enables fast, consistent deployment, thus ensuring that the applications can be easily scaled up or down based on demand. Container orchestration platforms like Kubernetes provide automated scaling and management capabilities, thus making it seamless to handle complex deployments and scale applications efficiently. Now let's move on and have a brief overview of Docker and Kubernetes. If I talk about Docker, then Docker is an open source platform emerged as a game changer in the containerization space. It allows developers to build, package, and distribute applications as containers. With its easy to use command line interface and extensive library of pre-configured images, Docker simplifies the process of containerization. If I talk about Docker, then Docker is an open source platform emerged as a game changer in the containerization space. It allows developers to build, package, and distribute applications as containers. With its easy-to-use command line interface and extensive library of pre-configured images, Docker simplifies the process of containerizing applications, thus enabling developers to focus on writing code rather than dealing with complex deployment configurations. Moving on to our second contender, we have Kubernetes. If I talk about Kubernetes, we encounter a robust container orchestration platform. Developed by Google, Kubernetes automates the deployment, scaling, and management of containerized applications. It provides a comprehensive set of tools and features that enable organizations to efficiently manage their containerized infrastructure at scale. With Kubernetes, developers can easily deploy applications across multiple hosts, ensure high availability and fault tolerance, and take advantage of advanced networking capabilities. Throughout this video, we will explore the differences between Kubernetes and Docker, examining their architectures, features, and use cases. We will delve into topics such as scalability, orchestration, networking, resource utilization, and high availability. By the end of our discussion, you will have a clear understanding of the strengths and trade-offs of each platform, thus empowering you to make informed decisions when choosing Kubernetes and Docker for your containerization needs. So without further ado, let's embark on this exciting journey and explore the fascinating world of Kubernetes and Docker. So let's move on and understand Docker. So guys, you can see a question all over here, and the question says, have you ever wondered how modern applications are developed, deployed, and scaled with ease across different environments? And the answer it says, well, the answer lies in a powerful tool called Docker. So I hope so guys, you would have got a brief idea what the question was about and what we have the answer. So if I talk about Docker guys, Docker is an open source containerization platform that has gained tremendous popularity in recent years for its ability to simplify the deployment and management of applications. It revolutionized the way developers package, distribute, and run applications by introducing the concept of containers. At its core, Docker enables developers to create lightweight, self-contained units called containers. These containers encapsulate an application and its dependencies, thus ensuring that it runs consistently across different computing environments, regardless of the underlying operating system or infrastructure. By using containers, developers can avoid conflicts between dependencies and eliminate the notorious as it works on my machine problem. Docker operates on a client-server architecture. The Docker engine is the heart of the platform that acts as a runtime for container. It runs on the host machine and manages the creation, execution, and termination of containers. A Docker engine uses container images as the building blocks for dependencies and the runtime environment. Docker images are stored in registries such as Docker Hub or private repositories, thus making it easy to share and distribute containerized applications. With Dockers, developers can easily build and customize their own images using Docker files, which are text-based configuration files that specify the steps needed to create an image. This declarative approach allows for version control and repeatability, thus ensuring that application's environment is reproducible across different stages of development cycle. Furthermore, Docker provides a wealth of features and benefits. It offers efficient resource utilization as multiple containers can run on a single host without conflicts. It supports rapid application deployment, allowing developers to spin up containers quickly and easily. Docker also promotes scalability and isolation, thus enabling applications to be scaled horizontally and ensuring that each container operates independently. In summary, Docker has really revolutionized containerization by introducing a user-friendly and efficient platform for packaging and deploying applications. It simplifies the development workflow, enhances portability, and promotes collaboration among teams. Understanding Docker is essential for anyone looking to leverage the power of containerization in their software development and deployment processes. Now let's move on and explore Kubernetes. Kubernetes, often referred to as K8s, is a powerful container orchestration platform designed to manage and automate the deployment, scaling, and management of containerized applications. It is developed by Google and now maintained by the Cloud Native Computing Foundation. Kubernetes has also become the industry standard for managing containerized workloads. At the core of Kubernetes lies a distributed architecture that comprises several key components. The master node acts as a control plane and coordinates over all operations of the cluster. It includes components such as API server, etc, scheduler, and control manager. The worker nodes, on the other hand, host the actual container and executes the workloads. Each worker node runs the Kubernetes runtime called the kubelet along with a container runtime interface or CRI that interacts with the container runtime such as Docker. One of the key features of Kubernetes is its ability to provide automated container deployment and scaling. It allows developers to define the desired state of their applications through declarative YAML manifests or using high-level tools such as Helm charts. Kubernetes takes care of ensuring that desired number of replicas are running, automatically scaling the application based on defined rules or metrics. This scalability ensures efficient resource utilization and the ability to handle high traffic loads. Kubernetes also provides advanced networking capabilities as it assigns each container a unique IP address and provides mechanism for service discovery and load balancing. Containers with a Kubernetes clusters can communicate with each other through these IP addresses or via services and endpoints. This networking flexibility facilitates building complex microservices architecture. Furthermore, Kubernetes ensures high availability and fault tolerance. It constantly monitors the health of the containers and automatically restarts or replaces failed containers. It can also distribute workloads across multiple nodes to prevent a single point of failure. These features contribute to the resilience and reliability of applications running on Kubernetes. In summary, if I have to say, Kubernetes definitely provides a robust infrastructure for managing containerized applications at scale. Its distributed architecture, automated deployment, scalability, advanced networking, and fault tolerance capabilities make it a preferred choice for organizations handling complex containerized workloads. Understanding Kubernetes is very crucial for effectively managing and orchestrating containers in production environment. Now let's move on and understand the differences between Kubernetes and Docker. So we are going to have a comparison based on the following points: container management, scalability, service discovery, and resource utilization. So if I talk about container management versus containerization, one of the key differences between Kubernetes and Docker lies in their primary focus. Docker primarily focuses on containerization, thus providing a platform for building, packaging, and distributing applications as container, where it simplifies the process of creating and running containers, thus making it easy for developers to isolate and package their application with their dependencies. On the other hand, Kubernetes focuses on container management and orchestration. It provides a comprehensive framework for automating the deployment, scaling, and management of containerized applications across a cluster of nodes. If I talk about scalability and orchestration, Kubernetes shines when it comes to scalability and orchestration. It provides robust mechanism for automatically scaling applications based on defined rules or metrics. It can horizontally scale applications by adding or removing container replicas, thus ensuring efficient resource utilization and ability to handle high traffic loads. Kubernetes also offers advanced orchestration features such as rolling updates and rollbacks, canary deployments, automated load balancing, which allows for seamless application management and zero downtime deployment. Docker, while capable of scaling application, does not offer the same level of native orchestration features such as Kubernetes. If I talk about networking or service discovery, networking and service discovery are critical aspects of containerized applications. Kubernetes provides advanced networking capabilities out of the box. It assigns each container a unique IP address and provides built-in service discovery and load balancing mechanisms. Containers within Kubernetes clusters can communicate with each other using these IP addresses or through services and endpoints. Docker, on the other hand, relies on external tools or manual configuration for achieving similar networking functionalities. And finally, if we talk about resource utilization and efficiency, which is a crucial point, then we will learn that efficient resource utilization is crucial for optimizing infrastructure costs and performance. Kubernetes offers sophisticated resource management features, allowing fine-grained control over resource allocation. It provides mechanism for defining resource limits and requests for containers and ensuring that applications receive the necessary resources while preventing resource contention. Kubernetes also supports auto-scaling, dynamically adjusting the number of replicas based on workload demands. On the other hand, Docker, although efficient at running containers, lacks the same level of sophisticated resource management capabilities provided by Kubernetes. And if we talk about that's an additive point, that is high availability and fault tolerance, then high availability and fault tolerance are essential for every application. If I talk about Kubernetes, then it is designed with built-in mechanism to achieve high availability and fault tolerance. It constantly monitors the health of containers, automatically restarts or replaces the failed containers. It can distribute workloads across multiple nodes to prevent single point of failure. Kubernetes also supports features like replica sets and stateful sets, which provides resilience for stateless and stateful applications respectively. Docker, while capable of running containers in a fault-tolerant manner, relies on external tools or manual configuration for achieving high availability. So this was the differences. Now if we look at this table, so we will learn that if I talk about containers, then Docker provides 8 containers per host, whereas Kubernetes provides 3 lakh container. So as you can see, Docker is priced at $288 per year, plus there are some free trials available with Docker, whereas Kubernetes is priced as free. If I talk about the learning curve, then Docker is simple, and whereas of Kubernetes, it is little bit steeper. Now let's move on and discuss the conclusion. Now the first question comes in our mind, which to choose, Docker or Kubernetes? Then we have to understand the following requirements or parameters, that is understanding scope, scalability, and infrastructure and deployment needs. If I talk about understanding the scope, then you have to understand that Docker and Kubernetes serve different purposes. Docker is a containerization platform that allows you to package applications and their dependencies into lightweight portable containers. It focuses on building and running containers on a single machine. On the other hand, Kubernetes is a container orchestration platform that manages and scales containers across a cluster of machines. It provides advanced features like automatic scaling, service discovery, and load balancing. Consider the scope of your deployment. If you need to manage a single container or small number of containers, Docker might be sufficient. But if you require automated management of large number of containers and want to leverage advanced orchestration capabilities, then Kubernetes is definitely a better choice. Now let's understand the scalability. If your application requires scalability and high availability, Kubernetes provides a robust solution. It automates the container scaling, load balancing, and fault tolerance, thus making it ideal for complex and dynamic environments. Whereas Docker, on the other hand, is more suitable for simpler deployments, such as running a single application or a few containers on a single machine. So consider the complexity of your application and scalability requirements when making a decision. If I talk about infrastructure and deployment needs, then first of all, consider your infrastructure and deployment requirements. Docker can run on a variety of platforms, from laptops to servers and cloud environments. It provides flexibility and portability, thus allowing you to run containers almost anywhere. Whereas Kubernetes, on the other hand, is designed to manage clusters of machines. It requires a more substantial infrastructure to operate efficiently. If you have a small-scale deployment or want to leverage specific cloud provider feature, Docker might be a better fit. If you have a large infrastructure or require advanced orchestration capabilities, then Kubernetes is worth considering. Ultimately, the choice between Docker and Kubernetes depends upon the specific needs of your application, the scale of your deployment, the expertise of your team. In some cases, using both technologies together can be a viable solution, with Docker as a containerization platform and Kubernetes as an orchestration layer. Now guys, if I talk about the future trends and scopes, do you know that as a container technologies continues to evolve, it is crucial to stay updated with the latest trend and best practices. Both Kubernetes and Docker have vibrant communities and active development, ensuring ongoing improvements and advancements in containerization ecosystem. By staying informed and understanding the strength of each platform, you can make informed decisions and leverage the power of containerization effectively. That was all for today's session, guys. I hope so you would have enjoyed our today's video on Kubernetes versus Docker.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.